Solutions by Justin, Alex, Kevin, and Peter. Please join us as we verbally and visually guide you through this marvelous journey of scientific inquiry and discovery, stimulating your curiosity and tantalizing your thirst for knowledge. Alright, so what is a solution, solvent, or a solute? Well, a solution is a homogeneous mixture of two or more substances in a single phase. The dissolving medium in a solution is called the solvent, and the substance dissolved in a solution is called the solute. In a solution, atoms, molecules, or ions are thoroughly mixed, resulting in a mixture that has the same composition and properties throughout. Next, a suspension is when particles in the solvent are too large that they settle out. Unless the mixture is constantly stirred, mixed, or agitated, the particles of suspension can be separated from a heterogeneous mixture. One example of this is a jar of muddy water. If the jar is left to sit, the soil will sink to the bottom of the mixture since it is denser. Separation can be done using filters to separate out the mixture. Colloids, also called colloid dispersions, are particles that are intermediate in the size between those in the solution and suspensions. They are small enough to be suspended throughout the solvent by the constant movement of the surrounding molecules. Particles that range from 1 nanometer up to 1,000 nanometers in diameter could form colloids. This picture shows the relative sizes in between each particle for the colloidal solution versus a true solution and a suspension. Also, with the example of the muddy jar, even after the soil sinks to the bottom, the water still has residual effects, which are the colloidal particles which are dispersed in the water. In the jar, colloidal particles make up the dispersed phase, and water is the dispersing medium. Some terms to note are emulsion and foam, which refer to specific kinds of colloids. Mayonnaise is an emulsion of oil droplets in water.
Based on what we previously learned on the past slide, the Tyndall effect is the scattering of light when light passes through a colloid. When hitting the colloid, the beam scatters and reflects the light, making it visible. 19th century physicist John Tyndall created the Tyndall effect. One example of the Tyndall effect is when light is projected onto milk, causing the light to reflect. At the bottom of the slide, there is another example of car headlights reflecting off fog. Electrolytes are substances, when put into a solution, dissolve into ions. These ions conduct electricity. Non-electrolytes also dissolve into a solution, yet they dissolve into molecules, not ions. This causes the solution to not conduct electricity. Electrolytes give you energy, including energy you need for muscle contraction. An example of an electrolyte is salt. When dissolved, salt turns into sodium ions and chlorine ions. An example of a non-electrolyte is sugar. Sugar doesn't turn into ions when dissolved. There are three main ways to speed up the rate of a solution will form. The first way is changing the surface area of the solute. The more surface area a solute has, the more places the solvent can reach. Grinding up a solute will majorly decrease the dissolving time than keeping it in its original state. For example, 10 small cubes have much more surface area than one big cube of the same volume, so they dissolve much faster. You can easily see this concept in the picture below. The second way to speed up a solution is to agitate the solution. Agitate means to stir the solution. Stirring the solution helps the solvent and solute mix, speeding up the process of turning into one product. In the first picture, you can see what would happen if you stirred versus if you didn't stir the mixture. The picture with no stirring isn't fully mixed together and still has salt on the bottom of the beaker. The picture with stirring is fully mixed together. In the second picture, you can see a stirring rod mixing salt into a solution.
Created using Powtoon.